So in this video, we are going to look at some practice questions. That's the idea that we are going to cover. So, we have studied about all the Armstrong's axioms. So now let's apply those axioms so that we can have a clear understanding on how to use these axioms. Okay. Let's say we have F. Yeah. F is a set of FTs in a specific relation. Let's say the relation name is R. And let's say F has the FTs A functionally determines B functionally determines C, and C functionally determines D. Okay. So the first question is show that A functionally determines D by using proper axioms. That's the first question. And let's try the second question. Find F plus the closure set of F. The closure set of F. Well, let's try. Take time if you want to pause the video and try the questions and recheck your answers with me, or you can watch the video continuously. So let's try the question. First of all, they are asking us to show that A functionally determines D by using proper axiom. Well, since A functionally determines D, let's number them. Instead of using them, let's number them. Let's say this is 1, let's say this is 2, and let's say this is 3. So from 1 and 2, from transitivity of 1 and 2, we can say A functionally determines C. Why? A functionally determines B functionally determines C. So we can say A functionally determines C. That's what I have applied here. Now let's say this is 4. From transitivity of 3 and 4, we can say A functionally determines D. So we have found the answer. You may think, is this the method to write the answer? I prefer this method to write the answer, but it takes time. So you can directly say A functionally determines C. What's the reason? 1, 2, transitivity. This is also another possible way of answering. There are no exact way to answer these questions. I'm just name this as 4. Just answer these questions in a way that your examiner can understand. Okay, your examiner can understand. 3, 4 from 3 and 4. So 3 and 4 and transitivity. We can say A functionally determines B. Okay, so now let's find the closure set. Okay, F plus is equals to, this is closure set of F. That is the closure set that I'm mentioning is FDs. Okay, FDs, not the attribute closure. Okay, attribute closure is a different topic that I have not covered yet. I will be covering in the future. That's not covered yet. But this closure set means the FDs, the closure set of FDs. Okay, so we know A functionally determines B functionally determines C, and C functionally determines D. Okay, so I can say A functionally determines C. Okay, that can be derived from this. Also, A functionally determines D. That's also I have derived it. And we can say B functionally determines D. That's also possible. Okay, so this is F plus. Other than that, you can use unions if you want. For example, if you say A functionally determines, you can say A functionally determines B, C, D, B, C, D. Why? You can use the union operation here. Why? A functionally determines B, A functionally determines C, so A functionally determines D. So you can also include this if you wanted. Okay, that is also derivable. Okay, so why is this important? Why deriving this is important? Well, see, this set of attributes A actually functionally determines B, C, and D. This means A can be used as primary key. A can be used as primary key. So you can also mention A functionally determines B, C, D, and we also have B functionally determines C, D. That's also possible. This you can apply. Other than that, we don't have any decomposition. Obviously, there is no pseudo transitivity, and we don't have any other transitivities. Just this. Okay, there are no subset things. You can say A functionally determines A, but that's not important yet, so we don't care about that. And yeah, that's all. That's all in the first question. Shall we try another question? Shall we try another question? Okay, let's try another question. Let's say there is a question like A functionally determines B and A functionally determines C. Say this is the set F. Okay, F set is this from relation R. And B functionally determines C and C functionally determines E and A functionally determines D. And let's say the question was to show that A functionally determines B, C, D, E. That's the question. What are they asking us to prove? The set of attributes A can be used as primary key. That's all they're asking us to prove. From this, what's the conclusion that we can come to? The conclusion is the set of attributes A can be used as primary key for this relation R. That's the idea behind this. Shall we see? See, A functionally determines B, A functionally determines C. To show that A functionally determines B, C, D, E, I just have to mention A functionally determines E. If I prove that, I can use that, and finally I can apply some unions. So we have 1, we have 2, we have 3, we have 4, we have 5. So what I'm going to do is, well, let's use 2 and 4, shall we? Let's use 2 and 4. Let's use 2 and 4. So from transitivity of 2 and 4, A functionally determines E. How is that possible? A functionally determines C. So A functionally determines C. C functionally determines E. C functionally determines E. So I can say A functionally determines C. Or you can say like this. A functionally determines E. Reason 2, 4 transitivity. Well, after this, it's simple. Why? Let's say this is 6. So we can say A functionally determines BC from what? By using 1, 2 union. And then let's say this is 7. And now I can use A functionally determines BCD. How can I do that? By using 5 and 7. By using 5 and 7. Union of 5 and 7. Union of 5 and 7. And then let's say this is 8. Okay. Let's say this is 8. So A functionally determines BCDE. How is that possible? I'm using 6 and 8. The union of 6 and 8. Alright. So this is another questions completed without any issues. I think this was not hard for you. Okay. I hope this was not hard for you. Now let's try another question. Shall we? Let's try another question. So they're saying A functionally determines B and B functionally determines C. And also they're saying AB functionally determines D. They are asking us, let's say this is G and relation R1. So we have to find out G plus. That's the question here. Okay. So we know A functionally determines B, B functionally determines C. So we have A functionally determines B. So what can we come up with? Okay, we have A functionally determines B. So we can say A functionally determines C. That's another thing. So from this, we can come to this conclusion. Other than that, let's use 2. Yeah, let's use 2. So if you use 2, and if you use augmentation, AB will functionally determine AC. So I can say AB functionally determines C. How can I say that? Well, good question. I have used decomposition. Here. And in this case, in 2, I have augmentation. I have augmented C to that. So I have that too. So finally, I have AB obviously functionally represents A. I know AB functionally determines B also. This is reflexivity. So, but they are not very hard. AB functionally represents C is also there. AB functionally represents D is also there. So G plus equals to A functionally represents B, A functionally determines C, B functionally determines C, AB functionally determines BCD. Actually, ABCD. Yeah, say ABCD.
So these are the important ones. But the thing is, shall we go deeper here? Okay. So we have AB function determines ABCD. Yeah. AB functionally determines ABCD. But the thing is, if we can divide this, yeah, if we can divide this, we can say AB functionally determines A as given here. AB functionally determines B. Okay. But the thing is, okay, but the thing is, A functionally determines B is already given. A functionally determines B is already given. Okay. A functionally determines B is already given. And we also have AB functionally determines ABCD. Okay. So here I can actually apply what we call pseudo transitivity. Okay. So if I say this is X and Y, if I say this is X and Y, okay, here, okay, XY functionally determines some Z. Okay. So here instead of Y, we can replace with X. We can replace it with X. Yeah. That's what pseudo transitivity tells us. Yeah. That's what pseudo transitivity tells us. What does it say? Hmm? What does it say? Pseudo transitivity say that if X functionally determines Y and WY functionally determines Z, we can say WX functionally determines YZ. So not YZ, WX functionally determines Z. Okay, WX functionally determines Z. That's what I'm doing here. I have A functionally determines B and AB functionally determines ABCD. That's what I have here. So I can say AA functionally determines ABCD. Okay. So, but the thing is, here we have to be very careful. We know AA is nothing but nothing but A. So we can say A functionally determines ABCD. So the primary key here will be A. Okay, this is the candidate key. This is the one and only candidate key here. So this is the only candidate key, and there are other super keys. I mean, AB is a super key. Okay, AB is a super key, but think of it. I mean, it's a super key with a subset. Okay, with a subset A. Okay, AB has a subset A, which is a proper candidate key. So AB cannot be primary key here. Okay, A will be the primary key here. You understand? A will be the primary key here. Okay, so here I can add another one. Okay, I can't just close the closure. I can also add another one. Okay, I can also add another one that says A functionally determines ABC. So keep that in mind when you're doing questions. Okay, keep that in mind. So this is the third and last question that I wanted to check today. Okay, tomorrow we will be doing questions on candidate keys. Okay, how to find the candidate key. So please keep in touch, stay tuned, because that will be more important than these three questions. Okay, these three were really easy. Mainly it was on transitivity. Yeah, there was no pseudo transitivity except for this question, last question. So keep that in mind, and let's meet in the next video. Yeah, so yeah, that's it. Thank you for joining this detailed session on solving Armstrong's Axioms questions. If you enjoyed this video, like this video to show your support, share it with your friends and peers. Subscribe to the channel and hit the notification bell to stay updated with more in-depth lessons in this series. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.